In this video, we're going to discuss polynomials and polynomial functions. These are the objectives for this lesson. You might want to jot these down in your notes. So pause the video for a moment, then come back when you're completed. Our vocabulary with this lesson: term is a number or a product of a number and variables raised to powers. The coefficient is actually the numerical factor of a term. A constant is a term which is only a number. There are no variables with it. And the polynomial is a sum of two terms, or sum of terms involving variables raised to a whole number exponent, with no variables appearing in the denominator. On page 271, it shows you several examples of what polynomials are not. So in this polynomial, we have four terms. The coefficient of the first term is 7. The second term is 1. Our third term is -4. And finally, our final term is 7, with 7 being a constant term. Notice there are no variables with it. The different types of polynomials: there's a monomial, it has one term. Binomial has two terms. Trinomial has 3 terms. If you've got 4 terms, that's considered a polynomial in 4 terms. 5 terms would be a polynomial in 5 terms. Degrees. Identifying the degree of a polynomial is very important for later work with factoring and solving equations. To find the degree, take the sum of the exponents on the variables contained in the term. The degree of a constant would be 0. So let's look at this term. 4, 3, 1. 4 plus 3 plus 1 is 8. So the degree of this term would be 8. The degree of a polynomial is to take the largest degree of any term of the polynomial. So the largest degree would be 3. So this polynomial has a degree of 3. This section is a review of distributing and collecting like terms. Like terms are terms that contain exactly the same variables raised to exactly the same powers. Only like terms can be combined through addition and subtraction. For example, we're going to combine the like terms in order to simplify this. First of all, let's group our like terms together. Notice we have x squared y and a 10x squared y, so we put those close together. Move our terms with xy together and our terms with only a y together. Once they're grouped, 1 plus 10, 1 plus 1, and a -1 minus 2. We end up with 11x squared plus 2xy minus 3y. When we add polynomials, we simply combine all the like terms. First of all, we're going to get rid of the parentheses. Then we're going to group our like terms together in order of degree. So 4x squared will become before x to the first power and then before our constants. Our constants will be last. Then we're going to combine our like terms. Notice 3x, they cancel each other out. So we have 4x squared minus 5. Subtracting polynomials, we're simply going to add its opposite. It's very important not to forget to distribute this minus sign across both terms in the parentheses. That will give us 4 plus y plus 4. Written in descending order, y to the first comes before our constant, so our answer would be y plus 8. Here we have a longer polynomial. Here we've got a minus, so don't forget to distribute that minus across both of those terms. So first of all, we get rid of the parentheses. Then we're going to write our polynomial in descending order, well, grouping our like terms together, but in descending order. -1 minus 1 plus 5 will give us 3a squared, minus 6a, plus 1, 3, and 7 is 11. In the previous examples, after discarding the parentheses, we would rearrange the terms so that like terms were next to each other in the expression. You can also use a vertical format in arranging your problem so that like terms are aligned with each other vertically. One mistake students do when they're aligning vertically is they forget to distribute the minus sign. So you'll have to watch that if you choose to do the vertical method. Using the degree of a polynomial, we can determine what the general shape of the function will be before we ever graph the function. A polynomial function of degree 1 is linear. We have examined graphs of linear functions in great detail previously in this course and prior courses. Polynomial function of a degree 2 is quadratic. Written in this form, the graph of the parabola opens up when a is greater than 0, and when a is less than 0, it will open down. So here a is greater than 0, and on this one a is less than 0, so it's negative. And finally, the polynomial functions of degree of 3 are cubic. Cubic functions have 4 different forms depending on the coefficient of the x to the third term. These are positive and both of these are negative. All right, you're ready to begin working on the assignment.